Good morning, folks. Sorry, the core stand up is going a little over. I imagine hopefully Josh and a couple other folks might be able to make it soon, though. All right, maybe we should just get started here. Oh, good, there's Josh. All right, I actually don't have a whole lot this time. I have to apologize. I was trying to do like 3 things at once this morning and forgot to go through the PRs. So next week, I guess we'll have 2 weeks worth. But there's a couple of different things going on right now. Maybe I'll highlight Igor's continued work with the bitmap allocator, and I think that Adam has been reviewing that, which is good. I'm very, very hopeful that we're going to see some better behavior with that versus stupid allocator, and especially versus the old bitmap allocator. I'll talk a little bit maybe about the cache balancer work, which has had some updates, but maybe do that a little bit later. Let's see. Yeah, I don't know how much other new stuff there is this week. I'll have to look next week and see how much of it I can cover there. Radek, do you know of anything else new that's interesting that's worth highlighting?
Hello. I guess there is a thing related to the priority queue we are using in sharded op work queue. In profiling, I can see there's that we have a lot of memory allocations made in a way that is not friendly to tcmalloc. The issue is that we are enqueuing an op in Messenger while dequeuing in TPOS-DTP. This means that many times the deallocate needs that the allocator needs the tcmalloc needs to employ its shard pool, a pool shard between all threads. The reason for that is that we are that the weighted priority queue is implemented in a way that calls many times allocates many times for enqueuing a single op. And moreover, we do that under shard lock. So it's even it has more coarse granularity even in comparison to pglog. I plan to take a look on that and talked already with Sage about that. I considered I asked Sage why it's pretty complex thing. It looks that 2 years ago there was a discussion, there was a focus on making the queue more fair to avoid starvation. That's the thing I would prefer to focus on after the buffer after the huge page circulation I'm working on right now.
Cool. Yeah, I do remember seeing some contention in various circumstances there, so it's probably a reasonable thing to look at.
I can see in profiling, I can see we are spending around 5% of cycles of wall TP or SDTP. But in scenario assuming 100 cache hit in Bluester, so it's I would say it could be a problem only on very fast devices. For ADDs, it's pretty insignificant, I would say. Yes.
Oh, sure,
Yeah.
sure.
Yeah.
I was wondering if you had I think Message made this suggestion yesterday to make, I guess, a benchmark that would just test the performance of the NQ and DQ through the shared work queue.
Makes sense.
I guess as long as we can capture that same kind of, submitting from one thread and deallocating from another thread to make it more similar to what the OSD is doing.
Sounds like a good idea, Josh.
Yeah, I'm glad you're looking at the area though, because like you said, it hasn't really seen much activity in a little while, so it's probably right for optimization.
Also, there is it could participate to the difference in performance I am observing when on different sizes of thread pool. Actually, in some scenarios, I can squeeze much more IOPS from having single thread, single TP or SDTP, than from huge pool of them.
Yeah.
It seems to me that the cost of pthread signal is actually variable. When there is no waiter, it's basically talking an atomic, nothing more. But if you actually, if the condition variable, if somebody waits on a condition variable, well, then pthread signal or broadcast could become costly because of syscall.
Yeah, that makes sense. That's go ahead, Mark.
However, all that. Actually, please continue.
I was just going to mention that it'd be very interesting to see whether or not that also changes or is more pronounced with the different security, kernel security patches that are now out there for both Intel and AMD processors. Just the comment you made about the variability of the performance impact, especially related to the syscall, makes me wonder if the Spectre and Meltdown patches may have an effect on this.
Definitely could have. I can recall that when some time ago, when I profiling the code for syscall, I was observing a ratio around between 5 or between 5 and 7 syscalls per single operation.
Wow.
Most of them were Futex.
Okay. Huh. Did it look like it would be possible to reduce that significantly or easily in any cases?
I put a lot of hope in C-star.
Yeah, okay. As do we all.
But actually, we could try some small optimizations. I mean, very small optimizations by default. At least on my glibc, that I'm running both on Incerta and also my laptop. I can see that the default implementation of pfread mutex doesn't spin. It means that if the user space part of the mutex is contended, then you are going to kernel. Then you are calling the mutex syscall. There is glibc offers some kind of adaptive mutexes, but you need to tell it explicitly when to use that. So by default, at least all the two versions I was taking a look on, they are not spinning. I made a small patch, small utility called called spinning guard or something like that. The idea was to call try lock a couple of times, interleaved with the pause instruction that x86 offers. In some situations, I was seeing significant improvement on the cost of synchronization.
So yeah, I guess it might be worth trying then, trying that in this case, since this does seem like a place where we happen to be contended on cross-thread things. How exactly is it enabled? Is it like can you do it on like a per mutex basis? Just how you?
Yes, it's basically a matter. I see two ways. First of all, it's just to prepare initialize a mutex. It could be in such way we could touch our abstraction over mutexes. Second thing is to change, to alter the way how we manage the lock. It's we just can replace some unique locks or unique guards with the trying guard.
Mm-hmm. Yeah, that might be a good area of investigation. It's worth some experimentation, probably.
Another degree of freedom is support for Intel TSX, transactional memory. glibc got patches enabling that. For mutexes, our distro vendor can enable that acceleration by default. However, for read-write locks of glibc of pthread, the TSX code is enabled by default, and this can actually have some costs related to cancellation of continuous, of permanent cancellations of TSX transactions, which can happen because because having too large critical sections. And I'm afraid that's the case of of our read-write logs, especially the one in Bluestar that is guarding really huge pieces of code.
Wouldn't it
It's
make
collection.
sense?
It's collection lock, if I recall correctly. Collection lock in Bluestar is implemented as read-write lock.
My impression was that the transactional memory stuff worked better for areas, since it's optimistic for areas that were less contended as well. Is that correct?
It depends. It depends whether on the size of critical section and also on the pattern of memory accesses over critical section. If you are touching things that are not logically related, but staying on the same cache line, I guess you can get unnecessary cancellations of in TSX. Basically false sharing.
Right, that makes sense. That reminds me of a year or two ago, someone came to this meeting and gave a short presentation about some false sharing and stuff. I think the majority of it he pointed out ended up being from dout.
I can recall that. Yep.
That was Joe from the performance team, if I remember correctly.
That's right, yeah. So
and PMU, at least on Intel's chips, has some events pretty useful and pretty easy to use, easy to use for nailing down the false contention. Sorry, the false sharing.
cool.
But
I wonder if it's worth going back to that and
the question is, I guess, what is our path to C-star, our path to shared nothing?
Yeah, so I guess that's maybe a longer path since it's going to need Messenger v2 to be able to target different shards at least, and
what is current status of the wall effort? I hear that Kifu is returning to the messenger part.
Yeah, he's returning to writing what he's calling like an IO engine or AIO engine for making it simpler to interface with the C-star and the non-C-star code, so that we can start converting some pieces like the that aren't performance critical, like the mon client or the objector or the OSDMAP cache, to continue running in non-C-star threads while we have the main OSD running in C-star. We went over this a bit at CDM yesterday, so if you take a look at the Etherpad from that or the recording, I think that'll be pretty informative. But in terms of actually getting the sharding worked out and kind of removing the queue, I think that's a bit of ways off still.
Okay, got it.
All right. Does anyone have anything else that they'd like to talk about this week before I get into cache balancer stuff again? All right, I'm going to talk a little bit about this then. This is stuff I've been working on. I'm pretty excited about it. So the first thing I will mention is that there are PRs both for RocksDB and for Ceph for the first kind of piece of this, which is implementing the priority-based scheme for assigning memory to caches. The RocksDB one is in review, but they're moving kind of slow. But we do have a branch in our own fork of RocksDB that we can target. The Ceph PR is basically there. There was a bug that we found in a corner case where basically we didn't create a RocksDB cache if the cache size was set to 0. So we just had like a null pointer, which my code was expecting that it would be there. So that was easily fixed. So that's not a problem. But there's been a number of other issues that have prevented it from merging. In my own defense, those don't appear to be related to the PR. There was a bug in the BlueStore cache implementation related to uint64t conversion to int conversion that wasn't safe. That is fixed in the PR now. There's an added commit to fix that. And then there's a long-standing bug that our QA suite only picks up maybe 1 out of 30 times running a particular test, and I just happened to hit it when testing this. So that's actually about a year old in master. We haven't yet figured out what that is, but it does not appear to be caused by my PR. It was just happened to be picked up in the Ceph test object store run that I did. So hopefully that will merge soon. I think it's hopefully safe at this point. But the real kind of guts of this is in this other commit as a separate branch for age-based binning of the caches. The idea here is that we want to know how old things in the cache are. Or rather, we want to know kind of on a bin basis how many things are there that fit within certain age bins. So the idea here is we basically have a circular buffer of counters where each counter represents an interval of time. By default, this is 5 seconds, and we're keeping 720 of them, so 1 hour's worth. And that's separated out into 6 different priorities, 1 through 6. 0 is kind of a special case one. But the idea here, the kind of the current implementation has a 5-second bin for super high priority stuff, between 5 seconds and 30 seconds, 30 seconds and 5 minutes, 5 minutes and 60 minutes. And then if it's the data cache, it's actually offset 1 lower priority. So 5 seconds is actually at priority 2 instead of priority 1, and 60 minutes is at priority 6 instead of priority 5. The idea being that generally speaking, we want to prioritize O-nodes and KV cache over data cache. The kind of neat thing here is that in this prototype implementation, the effect of this, of all of this, doing the priority-based binning or priority-based allocation of memory to different caches, combined with this age binning scheme, makes the balancer dynamic in that it will shift memory around based on what's kind of happening on the cluster currently. So in some very, very initial tests of this, when filling up an RBD volume full of 4 megabyte writes for pre-allocation of the volume, it was keeping the data cache to around 75% of the total memory available, and assigning about 25% of that cache to metadata. So about 50% of the O-nodes are being cached by the time it finished. It was a 256 gigabyte volume. It got to the point maybe halfway through where it hit the total cache, the total amount of memory available cached, as it was kind of balancing. Oh no, I'm sorry, it was much earlier than that. The data cache had actually spiked way up, but but over time, it slowly gave Meta more, but it didn't give Meta everything, just because it was seeing such a large ingest of recent data. But as soon after it finished the 4 megabyte sequential writes, it started doing the test started doing 4 KB random writes, and immediately cache started switching over to onode cache, because as these writes were happening, onodes were being very, very rapidly accessed, and the amount of recent onode data started shifting much higher compared to data. So as a result, all of the onodes for most of the KB the 4 KB random write tests, except for at the very, very beginning when it was shifting, except for that case, all onodes were cached for the duration of that test, and basically all of the remainder was given to the data cache. The KV cache never exceeded about 1 to 2% because it was never really needed. There was no real need for the KV cache, because the only thing that was being really accessed were onodes, which were already in the BlueStore cache. So this I'm super excited about, because it's doing exactly what I was hoping it would do, which is kind of targeting the current use and kind of optimizing for what the current use case is. Right now, there's no provision in RocksDB for doing this, so I need to add this capability into RocksDB's caches and then expose it in the same way, so that we can also balance the KV cache in the same way as the data and meta cache are in this particular commit. But once we have that, and then once we start accounting for other things like the PG log data usage, the write ahead log buffers in RocksDB, the row cache in RocksDB, and potentially a couple of other things, we should be able to get a really good idea of where we're using memory everywhere and controlling where we're using memory everywhere. And especially if we're watching the assigned memory in tcmalloc, we should be able to then start dynamically changing the amount of memory we have that's available to work with, and try to, probably not we won't be able to guarantee it, but try to keep the OSD memory usage within some boundary that the user sets. So my goal with all of this is to make it so that we are keeping the OSD to a user assigned memory value, and then not requiring the user to define anything else. Just automatically we assign memory for everything, and I think it's doable. These results to me look really encouraging in terms of being able to have the OSD make smart decisions in real time about where memory should go. So I'm super excited about it. I know it's it's hard to be excited when you're not kind of in the midst of it like this, but it's I think it has a lot of promise. So
Yeah, I'm really surprised how well it's been doing already, even with the just basic metadata caching. How much that's improved RBD performance.
And it's almost kind of false though, to be honest, because really what it's doing is just like giving onode cache, giving RocksDB, or not RocksDB, BlueStore memory for onode cache, because that's the thing with RBD that really, like, once you're not caching onodes, performance can go way down.
Right.
So it's kind of
that's
like
the bottleneck there, basically.
Yeah, exactly. But on the flip side, if you don't need like all of your memory for onodes, you really want to be able, in the RBD case, to give it to data, so that if you have the settings enabled to cache data on kind of normal writes, you potentially could be doing like all of your reads from cache instead. So I think, especially for tests where we're doing like a what do you call it, a test where you're not doing like a random read over the entire volume, over the entire disk, but you're just doing like hot reads, like what do you call it, distribution?
Zipfian or
Yes. Yep. Exactly. Yep. I suspect for that, that's where it will really shine, because then you'll see a certain, most of the hot data residing in the data cache, and you can do those reads just from cache instead. Whereas if you were giving all of the cache to the O nodes, which we sort of used to do, then you wouldn't get any of that, or you'd get very little of that.
Mm-hmm.
So that's it. Any questions on any of that?
Something that just popped into my head was RBD on EC pools. I know this is still going to be probably not. I'm guessing this is not going to be as effective there, just because the bottleneck there is mostly going to be over the network, having to do the read, modify, write cycle a lot of the time. But maybe if we can get some of that, like that data cache going in, maybe it would help there as well. With that kind of distribution, it would be interesting to try out.
The EC case is really interesting too, right? Because you have a much larger number of O nodes.
Yeah, potentially. Not necessarily. You could still have the objects themselves being the same size. I guess you're saying that that there are more shards of the object, so that they're more. Yeah. Okay.
Yep. Because unless you have like a crazy replication factor, right? But
or you start making your logical objects larger to compensate, maybe.
Well, that's true too, I suppose. If you were going with like a non-standard object size in RBD, do people ever do that? I don't actually know.
I've heard of them doing that occasionally. Like Xsky, for example, was doing like 32 meg objects.
Okay. Wow.
But for the EC case, it's probably more important to reconsider what an optimal size would be for a given EC coding as well.
I suspect that it's going to be really difficult to nail that down exactly, since it's so dependent on so many different factors.
Yeah, there's a ton of factors there.
Yeah.
Many parameters that we could tweak.
Well, one of the things that's kind of nice about this, at least, is tweaking that, right? The object size and kind of how many shards you have and all this stuff really kind of changes the workload on the key value database. That's kind of where, like, for a small random IO workload, that's kind of the thing that you always see really getting hit hard. And it would be really interesting to see, if you start changing that kind of thing, how it changes the amount of data that's necessary to cache like KV data versus ONO data in BlueStore.
Yeah, that's a good point.
I don't think that we can ever really know in advance or guess in advance what these kinds of ratios should be set for to cover like all cases. I still very much believe that. But I think we can make something that's relatively smart about kind of like doing exactly this, balancing it out dynamically in real time. I'm very, very convinced this is the right way to go, but we'll see.
Yeah, I'm very excited about it as well. Looks like it's definitely heading in the right direction. So
I hope so.
Pretty cool to see.
Sage, you've been silent. any thoughts?
Yeah, I'm sort of only half listening. Sorry.
Okay, no worries.
Yeah, so I had a question. I can't remember where I was looking at it. I think it was in the pull request description or the email you sent or something, where you were binning things by time in the different caches, and you were skewing the time series. So a shorter, more recent data in RocksDB was the same priority as older data in BlueStore or vice
The
versa.
data pool.
Yeah, is that right? Okay.
Yes, that is correct.
Okay. I think my question is if we can accomplish the same thing just by looking at the oldest bin and the things that are falling off the cache, if that's going to work almost as well.
I remember thinking, I spent about a morning thinking about that for a couple of hours. And I remember, I wish I would have written it down because there was something I was really, really worried about that we were not going to, I felt like I was worried we weren't going to, it was not going to work well for. If we just do that, let's see.
I mean, you have to wait for things to fall off the cache. It'll be slower to respond because things have to fall off the cache, I guess. But the thing I worry about is the prototype you built that's basically having all these additional allocated ref count objects that are attached to everything that's in the cache is just adding all these allocations and ref counts to every object. And I'm just worried about the overhead that that's going to cause.
Sure. Yeah, I mean, it's basically like an extra, add or subtract operation per trim.
And allocation per object, right? Aren't you piggybacking these additional?
It would. Yep, it would be. Well, it's an extra. Yeah, it's an extra shared pointer to a uint64t.
Yeah, so it's an allocation. Yeah. Okay.
So it's like 720 right now. 720 bins. There are the counters, and then there's a shared pointer in for
into the bin.
Yep.
That's right. Okay. That might not be so bad.
So basically for every O node is an extra shared pointer.
It's an extra pointer traversal and a increment or whatever. Yeah. Okay.
Yep. I thought that probably wouldn't be that bad, especially compared to like storing a timestamp or something.
Yeah. I guess the allocation free doesn't matter because it's amortized across a zillion objects. It's really just a pointer. You have to do a pointer indirection to increment, and it's an atomic. But like whatever. It's if you can. Are you sharding it? Are you doing it per cache shard?
Yes.
Okay, so it should be fine. Okay. I'm still curious if the trivial thing would work as well, but I guess this isn't bad either.
So if we say we did the trivial thing, I'm trying to work through the logic I was thinking of when I was going through this. So maybe let's just retry it now and see if we can come up with what the behavior would be. So, okay, we wait for it to fall off, and that gives you kind of the maximum age of the cache, right?
Yeah, it's like the reuse interval or whatever. What's it called? MRC, maximum reuse curve. Is that what MRC stands for?
I don't know, actually, off the top of my head.
Miss rate ratio. Sorry, never mind. Okay, it's the reuse distance. That's what it is. Yeah, it's but it's not the reuse distance. It's the whatever. It's the time interval that your cache covers. Yeah.
And so you've got, in that particular case, you can say that you've got for a certain current size that this cache is this old or that cache is that old, right? and you could try to start tweaking them so that the ages end up being roughly the same, right? That would be the idea.
Yeah. Or some ratio. Like if you think that the data cache is less important, then you could target like 1/10 the age of the data cache as the metadata cache or whatever. Because if you're doing the binning thing and you're skewing the bin slightly, then at the end of the day, what falls off the cache is like off by 1 bin, right? Which is like what 9. And if you have 10 bins, then it's like 9.9, 90% or 110%, whatever, however you want to look at it.
Yeah.
So it feels like it's the same.
So I mean, ultimately, right now in this one, we're still looking at anything older than 60 or 60 minutes is just leftover whatever, but the curve looks different, right? In each case.
Yeah, but the curve is going to normalize once things start falling off, unless your workload continues to change, in which case you're chasing moving target. But
so like in this particular case, the really interesting behavior here was in like priority 1 and priority 2. That was where things rapidly changed, where like the switching over from a 4 megabyte workload to a 4 KB random write workload, all of a sudden the number of O nodes that were in like priority 2 or even priority 3 all immediately shot into priority 1. And the amount of the data that was hot shifted from being like priority 1, priority 2 to maybe more like a little bit in priority 1, a little bit in priority 2, and a lot in like priority 3. Does that kind of make sense? Like the sizes?
I understand what it means to bin the caches, to understand what the ages are. I'm trying to like reconcile that with the priorities. What's the relationship between the priorities and the bins?
So
is there something that's written down that you're looking at?
Oh yeah, sorry, it's in the Etherpad here. Okay. But it's basically just the same thing that I sent you an email the other day.
Okay. I see. Okay. Are these like time periods hard coded, or are they just like a ratio of the cache size?
Right now, they're hard coded intervals, so it's like currently the interval length is 5 seconds, so the cache balancer will run every interval, and that's user defined. And then these right now are hard coded, but that that can be changed. That's not a big deal. So like priority 1 is for the KV cache and for the meta cache, or sorry, the meta cache. Yeah, meta cache and KV cache is just one interval, whereas the first bin.
Next
and
one's
then
6 bins, and then.
Yeah, exactly.
Yeah. Okay.
Yeah. Exactly.
So this will more quickly respond because you'll start to notice once you're in like the priority 2 or 3 range that you have more objects in the O-node cache or whatever.
Yeah. So like when you're doing 4 megabyte writes, you'll have lots of O nodes in priority 1, 2, and 3. They'll be spread across them because you're not getting O nodes in fast enough that they all stay at a high priority. But once you switch over to like 4 KB random writes, all of a sudden you're accessing O nodes constantly, and they all shoot up into priority 1. And now data is almost like the situation reverses. Now instead of having like a ton of hot data because it's 4 megabyte sequential writes, it was that, right? It used to be 4 megabyte sequential writes, so you end up with like a ton of super hot data. Now, because you're doing 4 KB random writes, you end up with some hot data, but the amount of data that's in the cache ends up kind of more migrating down to 2, 3, 4, whatever. But O nodes are all super hot, so the stuff switches around. But if we just looked at like the age, like the maximum age of the cache, it wouldn't really like.
Well, the thing is, we don't actually. None of this matters until you start trimming things, right? Like, it doesn't matter that you have a lot of priority 2 O nodes and you don't have a lot of priority 2 data until you actually start trimming O nodes or trimming data that could be used. And so it doesn't actually matter until you start. If you start trimming O nodes that are like less than 5 minutes, that's when you start to worry, right?
When in these tests on the NVMe drive, really, really quickly we start trimming stuff really fast, especially
right.
with.
What I'm saying is that, so say you're shifting from a data heavy workload, and you've got like, say 90% of your memory is in data and 10% is in O nodes, and they're sort of equalized, whatever they're balanced, whatever that means, where so that the age of the stuff falling off the cache is roughly the same. Suddenly we have a very heavy O node workload, and so we start, priorities 1, 2, all those start filling up. Those bins get a ton of stuff.
Yep.
None of that matters until we actually get to the point where we would have trimmed an O node that is recent that we shouldn't have trimmed, right? Like, the only decision any of this ever affects is the actual thing that you're trimming at the very end. And so we notice that because the thing that we trimmed right before that is like, oh, it's only 5 minutes old instead of 30 minutes old. I need to like dump a bunch more memory over into the O node side and start pruning my data cache sooner.
For if you before you notice that, when you still have very little memory assigned to O nodes, but you have lots of data, you're going to end up with the KV cache also increasing really rapidly, right? Because you're doing these. I'm trying to remember exactly what.
I think it's so the hypothesis is that it's the same regardless of what your cache is. The only actual effect of changing the cache sizes is like whether you trim an entry or not. Like, that's actually the effect of all this. And so it's whether this entry that's n minutes old gets trimmed or doesn't get trimmed. And you can base that decision either based on this having this weird curve of priorities, or you could also just look at the age of the thing right before it, which is going to be approximately the same age that you trimmed. And so my thinking is that you could make the same decision based on that. Because by the time you get, say your priority 2 blows up because you're blowing out a bunch of O nodes, suddenly the things that are falling off the O node cache, instead of being 4 minutes old, are 3.5, then 3, then 2.5, then 2, then 1.5, right? And as that ramps up, you're like, oh my gosh, I got to start giving them more memory, and then they'll like equalize it at 2.5. You'll like actually just stop trimming them entirely. Or I mean, even if they were at 5, as soon as they go to 4, then you're like, oh, I'm going to give them more memory, and it's going to go back to 5 or whatever it is.
Maybe after the meeting, I think I maybe sent you something on IRC like a week or 2 ago. I don't know if you keep your IRC back that far, but yeah, I really wish I could remember what it was that I was worried about.
Yeah. Well, let's keep. Yeah, we can chase this down there.
Yeah, sure.
Anyway,
but the
results are awesome. So assuming we can prove these, assuming we can adjust these properly, then we're in great shape.
Yeah. The other thing too is the big part of all of this isn't just kind of making Ceph faster, but keeping what we have now while reducing the memory usage, right? Because that's really kind of part of this, is figuring out how to
use it
really
memory effectively. Yeah.
Because right now it seems like we're using too much memory, right? We're with 3 gigs of BlueStore cache, the OSD can use closer to like 7 gigs of RSS memory in certain scenarios. So we might have a future where we need to be able to operate with far less BlueStore cache.
Yeah. Yep. All right.
Well, that's all I've got. So, anyone have anything else for this week?
Not for me. Cool.
All right. Have a good day, everyone.
Have a good one.
See ya.
Same for you. Bye.